Okay, so our presenter tonight is Richard Wolff Jacobson, and he's coming to us tonight from California via Zoom. Richard is a software engineer and hobbyist designer with a passion for astronomy, vintage electronics, and an unusual form of factor computers. He's been observing the night sky for over 30 years with various commercial and home built telescopes. He's says he still often feels like a beginner, though. Richard's presentation tonight is titled Building the PiFinder. And in it, he's going to discuss the PiFinder, how it works, how to make your own. As I understand it, the PiFinder is a neat little gadget you can attach to your telescope that tells you where you need to point it to find your target. And so tonight, Richard's going to dive into how the PiFinder came to be, how its plate solving works, plus show you how you can build one yourself and tweak it to fit your own observing style. With that, let's give a welcome to Richard.
Thank you, Bart. Great intro, and thanks, Jack, for hosting and helping me get this all set up. That was a great introduction. In fact, it was so good. It's sort of my first slide. So I'm Richard. Nice to meet you all virtually here. I will be sharing this slide deck with everyone, so I don't feel the need to kind of read it all. But this is me. I think Bart covered the basics there. So this talk is about building the PiFinder. And that's sort of got two meanings, right? So it's got the meaning of how I built the PiFinder originally, and then also how you can build a PiFinder. So it's sort of both senses of the word, the history of the PiFinder and then the activity of building one. So I'll cover, what the PiFinder is, why it exists. I'll talk a little bit about how I built it the first time, the initial development. I'll talk in maybe too much detail about how it works. And then I'll talk a little bit about how you can build one of your own, because my intent has always been that people build their own PiFinders. So I will try to convince you that that is not a daunting task and that there is help along the way. And there'll be some questions at the end, of course, if I can manage the time effectively here. So what is the PiFinder? It is an all-in-one plate solving finder, a computer, but it's designed to be a device, a utility device that sits on a telescope and behaves much like a finder would, helping you locate objects in the sky. It's fully self-contained. It mounts just like a finder in sort of a standard dovetail shoe. It uses the sky itself as its mechanism for determining location. Some other bits and pieces here, but ultimately you put it on a telescope, it tells you where you're pointing, you tell it what you want to find, and it helps you to get there. The PiFinder is, though, also a community. So it's an object itself, but it is also a project. It is fully shared, both open source hardware and software. People contribute to it. Here's some examples of different PiFinders that people have built, remixed. And ultimately, the thing that I like most about it is all of the people involved in it. And I'll talk a little bit about that kind of right towards the end, but it's both things, the object itself and the community that's kind of grown up around it and has contributed to it. So why is there a PiFinder? Well, it started many years ago when I built a 16-inch telescope. That was a big step up for me from my 8-inch scope. And I started, pursuing dimmer, smaller, fuzzier objects. And I often found myself wondering if I was pushing the limits of my observational skills or the equipment or the sky, or frankly, if I just had star hopped to the wrong place. So I decided I needed a little bit of help, and I got a Nexus DSC Pro, a great device. It uses mechanical encoders to monitor the motion of the telescope and computes what it feels is the right sky position based on some alignment. I'm sure we probably have experiences with lots of kit like this. And it helped. It helped a lot. Not only did it help give me confidence that I was looking at the right part of the sky, which let me spend the time to go deeper in my observations, but I got to observe more throughout the night because I was spending less time going between charts and sky and star hopping for dim objects. But it didn't completely solve the problem for me. Because of the way that I had retrofitted it to my scope, you can see a photo here. It was not the most robust solution, and I'd often need to realign it. If I felt that I was looking at the right place in the sky and I didn't see that little galaxy I was looking for, I still had a lot of questions about whether I was actually pointing at the right star field, whether the particular galaxy was beyond the reach of my observing skills of the scope. So it helped, and it really whetted my appetite for what this sort of solution could provide to my observing style. And so I got interested in what I could do to improve this mechanically, the whole process. And I started to start from ground zero about what do I really want out of a system like this. And I decided I want more useful observing time. I don't know about anyone else, but I never get enough time under the stars. I wanted to use every minute of that the best of my abilities. So I wanted quicker setup and I wanted smoother operation. The realigning throughout the night, the uncertainty, that wasn't what I was really after, which kind of led into this better pointing certainty. I really wanted to know if I didn't see the object I was looking for, if it was my failing. And ultimately, it's always my failing, right? I'm either looking at the wrong spot or I'm just not seeing it where it is. But I wanted to disambiguate those two things. And I threw in a couple other sort of intermediate requirements. It needed to be night vision friendly. I wanted it to be customizable because I like kind of playing with things. I wanted it to integrate logging because that's a big part of my particular observing experience. And I wanted something that was fun and interesting. So I decided to build my own plate solving finder. I had seen similar things kind of bantied about. I knew a little bit from my astrophotography friends in the astronomy clubs what the power of plate solving was. And I wanted to see if I could really turn the plate solving experience into more of an appliance, a little device that actually just worked without a lot of feeling like a science experiment or feeling like I was tethered to a computer or something like that. I wanted sort of a Telrad that just told me where to go, essentially. So I started down this road of developing the PiFinder, and I generally like to start with the hardware when I approach a system that is some amount of hardware and some amount of software. I find that it's easier for me because I develop software for a living, so that part generally falls into place a little easier, and I keep my motivation up easier if I actually have the device itself that I'm programming rather than an emulator or some other system if I wanted to start software first. So I prototyped the hardware. I knew I wanted some keypad to enter some things, a screen. I knew I needed a camera for plate solving, and I kind of hacked this together. There's some examples here of the first kind of prototype. And then I dug into the software. I did some sketches, kind of what this might look like based on my experience with the Nexus. I knew I wanted some catalog searching. I wanted some arrows with numbers. So I knew how to move the scope, some other bits, and I started developing. And this is what I came up with circa December 2022. The same basic hardware, maybe slightly refined software that worked. It had the basics there. It showed the camera preview. It plate solved. You could do some catalog functionality. It could do chart plotting, and it pointed you where you needed to go. And as it was getting into winter, I'm fortunate enough to live in California, so winter is a fine observing time for us. It gets marginally cold, but I was able to take this out, and it worked. I was shocked. I put it on my telescope. I turned it on. I had tested it briefly, from my balcony, but it actually led me to many, many objects that night. I never had any issue with accuracy, and I was just shocked about how effective this was. So how does it all work then? Well, it's got two main components to determine position. And I talked a little bit already about the camera and the plate solver. That provides essentially 100% accurate positioning. If you can take a photo of the sky, it will solve it very rapidly, and it will tell you exactly where that photo represents. But that only works when the scope is stationary. If anyone's used an encoder-based system, one of the nice things is as you move the telescope, you can watch those numbers approach zero, and you kind of know when to stop moving. One of the issues with plate solving, as had originally sort of been worked up in a lot of these systems, is that you had to get your fix, move, wait for the next fix, kind of guesstimate the next amount of motion. And I really wanted to close that loop because I really enjoyed the immediate feedback of the Nexus. So I coupled the plate solver and camera with an inertial measurement unit, an accelerometer, and it will track the telescope motion while it's moving and offset the last plate position so that it can give me a pretty good estimate of what the position will be when I stop. It's fun to watch it, do a slight correction every time you stop and it gets that first plate solved, but it's definitely close enough to provide essentially real-time feedback while the camera is unable to take exposures. Combined with that positioning system is a suite of observing tools that I originally felt like I wanted, but has since grown with the collaboration of other people that have used the PiFinder. It has a robust catalog with, I think, pretty good filtering. One of the unique things is it has an image of every single one of the items in the catalog. The screen makes that possible. We orient these images as they look in the eyepiece. So if you're ever looking for how big is this galaxy, how much should I expect? Is the extent top to bottom, north to south? The system can actually work out where in the sky you're pointing, the mechanics of your telescope, eyepiece combination, and so forth. And it can give you a true to life representation of that based on the Palomar Sky Survey images. It provides push-to guidance, and it's got an equipment database. You can switch eyepieces to get the right previews. That kind of ties into the logging system, so you can record easily with just a couple button presses what you've observed through the night. And it integrates with SkySafari if you want to drive the pointing position, the telescope position displayed there, have access to things like comets, maybe some other transient items that the PiFinder didn't originally include in its catalog. All of that is driven by a collection of open source software tools. Some of that was written by me, other community members. It relies on a foundation of other open source tools. It runs on Linux, the open source operating system, Python, again, pretty popular in the open source space. It uses an open source solver that was originally developed by the European Space Agency for their satellites. Uses Skyfield, which is another open source project. So the story here is that this is really built through the efforts of other community members that I will probably never interact with, but I am fortunate to be able to stand on their shoulders, as the expression goes. And I decided that I wanted to release the PiFinder software myself as open source so other people could look at it, learn from it, modify it. So that's there. And that's proven to be a great benefit because people have contributed a lot of fantastic new features. The hardware itself is also open source. The reason you can build your own is because all the plans are made available, all the electronic files, the parts list, and I'll cover that when we come to building it. There's a bit of information here about the hardware, but we'll get into that a little bit later. The other question or answer to the question of how does this work is, deep in the sort of plate solving. And I think this is really interesting. So I'm going to go through this fairly rapidly. I was kind of amazed that this is a system that works so well. So as I said, it was originally based on the European Space Agency Tetra 3 solver. they developed that solver to essentially orient their satellites if there was no other information available. So just a camera looking at a star field, where is it pointing? How is it moving? So it's designed for what they call unhinted, so no previous information about where in the sky you might be looking, and rapid feedback, because if the satellite is orienting itself, that needs to be a pretty reliable and quick process. So the process of figuring out where in the sky a particular image is taken or where it represents is really split into finding all the stars, which is sort of an image processing chore, and then based on the pattern of stars, identifying it against a database. So you have these kind of two phases, and they each take a certain amount of time, and you want to try to do them very quickly. So the first step is to take an image like the one presented here and identify all the stars. So it's called centroiding. It figures out what looks like a star in that image based on a lot of factors. There's some really fun stuff about rejecting trees and airplanes and other stuff that is a deep kind of area of its own. I'm going to kind of gloss past that and just say that the centroiding produces an XY coordinate list of stars plus their perceived brightness by the sensor. Once you have that done, this is kind of that example of finding all the stars, generating a really strict set of points, removing all the other extraneous information. Then you can start looking for patterns. And the way that the Tetra 3 solver and subsequently Cedar, which was a fork of that's now being used and been improved, is it finds the 4 brightest stars and it numbers them from 1 to 4. In this example, I've gone ahead and done that. Then it takes the first and second star and it draws a line between them, and it says, okay, this is distance D, and you can see that here, first and second star. Then it goes and it compares all the distances between those stars as a percentage of D, so a ratio of D. And you can see here that it can draw all the connections between all the different stars, and it expresses them as some distance 1.5 times D, 4.8 times D, 5.1 times D. These all happen to be larger, but they could also be smaller because you're really looking at the distance between the 2 brightest stars, using that as your measuring stick, and then measuring the distance to all the other stars in the pattern. This then provides this sort of neat kind of hash or an address with all the distances sort of strung together. You can use this now numeric representation of this pattern to look up into a database a bunch of different patterns that have been pre-computed. I'll talk a little bit about that. To find the one pattern that looks like this one. The kind of interesting thing about this is that the pattern is the same regardless of the orientation of this and also the size. Because your measuring stick is the distance between the 2 brightest stars, it doesn't really matter if this pattern is small in the camera sensor or large. What the orientation of that particular pattern is, you're going to generate this same hash, the same sort of description, numerical description of that pattern. And that's kind of key to this whole thing. So what you do with that then is you compare it to a whole bunch of patterns that you've pre-computed. The PiFinder database currently has 118,000 stars down to magnitude 7. It's designed for the 10-degree field of view that the camera produces. And it has 712,000 patterns stored in an 8.6 megabyte file. This is kind of outdated. It can actually use 0.05 second exposures, so it can expose 20 times a second. That generally gets it down to magnitude 7 under reasonably dark skies, and it can feed that through the centroiding and the pattern generation and pattern matching in about 17 milliseconds. So it can do from soup to nuts, taking an exposure, solving it, generating a high confidence estimate of where that is in the sky, all I overlap that a little bit with some of the multi-threading, but it can essentially perform that up to 20 times a second. If your sky is a little brighter, you'll have to have a little bit longer exposure. Clouds and other things may kind of complicate that, so you may only get 5, solves per second. But that still means that if you randomly, move your telescope to any location in the sky, as soon as it settles down enough to take a photo, it should almost immediately give you a new sky position. So that's hopefully an interesting example of how this actually works behind the scenes. I found it to be one of the most interesting things that I learned in building the PiFinder. And how are we doing on time? Okay, pretty good. So if this is interesting to you and you'd like to try a PiFinder out, of course, you can purchase one fully assembled, but that came about as a secondary activity to helping people build PiFinders on their own. I originally intended this to be sort of a DIY project. That's how I built it. I released the software and the hardware designs open source on the web so anyone could build it. And I sort of thought that maybe a couple people would take up that challenge and build it. I ran a couple like kind of group builds with local clubs. But sooner or later, people started coming to me and they said, well, can I buy a kit or can you build one for me? And so it's kind of grown into that direction. But I would encourage anyone who has the skills and the time and the interest to really just build one yourself. I'm here and I help people regardless of whether they've purchased a kit or, essentially, helped support financially in any way. I, want people to build the system themselves, and I do my best to sort of support that. And I'll show you now that I think it's actually a pretty approachable project. So all of the plans and the build guide are available online. That includes the parts list, the manufacturing files if you want to get your own printed circuit boards made, everything you need to buy, everything you need to print. All the case parts are 3D printed. You could send that off to a print house, or you could, ask your buddy. 3D printers are not all that hard to find nowadays. So essentially, it's some combination of buying bits, printing bits, and then putting them together. I tried to bias all of the parts to readily available, fairly inexpensive, and off-the-shelf bits. At least in the US, these are all pretty easy to get. Mostly in Europe and other places, they're also pretty available. There's some substitutions there if some particular bits are out of stock, but I really try to center it around easy to find parts that could be hand assembled. So if you've done any amount of soldering in your life, I think this is an approachable project. None of the parts are too small. It's all through hole. You can see my fingers there for scale. I assure you I'm not an especially small person, so this is showing how approachable this is. I think the build guide has been pretty well refined now with the help of the community. So I think if you've done like an electronics kit at all before, this is going to be sort of that same thing and should be pretty approachable. All of the really tricky bits, like the GPS and the accelerometer, are on their own module boards. You buy that board and all you have to do is sort of solder them on to the carrier. Again, pretty easy stuff. And it has a high likelihood of success. Probably, I've interacted with, at least personally, many dozens of people who have built these themselves. I think that there's, well over 100 built in the wild. And so far, I've only run into a couple people that have completely failed to get a working PiFinder. And we've been able to help everyone else through, the little wrinkles and so forth. So I do feel like it's pretty approachable. And once you get past the electronics, if you can 3D print things or find someone to 3D print, the inserts can be a little tricky, but again, not that hard. And I think that the upfront cost and time, because they're super cheap, but the upfront effort to get these things embedded in the plastic with a hot soldering iron is well worth it, because the rest of the build then is really just a screwdriver and some screws. So this isn't meant to be a comprehensive guide, the build guide online is really specific about, part A goes to part B, but I just wanted to kind of give a flavor and try to convince you that this is an approachable project that you might want to do and maybe even have some fun. So once you get through the electronics, it's pretty much screwdriver, kind of IKEA-like. Everything goes together, I think, pretty sensibly. Nothing really too tricky. There's a little bit of like the ribbon cable that can be a little cumbersome for folks, but ultimately, most people who embark on this end up with a fully working PiFinder. They can do it in different colors. People are creative about how the case design works. And I think that there's, I don't know, at least for me, coming from a background of tinkering and making stuff, I just think there's something really cool about having something that you built yourself. Kind of ties into that amateur telescope making aesthetic, and I think that itch that some of us have. So happy to help anyone who wants to build a PiFinder to do so, because that's kind of I have a soft spot in my heart for folks that kind of do it themselves. So let's see where we're at. Okay, 8:30. I know it's getting late there. But I did want to talk a little bit about the unexpected impacts of this a couple years down the line. So the prototype I finished in December 2022, I think. So coming up on 3 years here in December. I really just wanted a PiFinder. I wanted something that could point my telescope, and I thought it would be cool to share that with the world, because that's kind of what I do with a lot of my kind of tinkery projects. And so I got a PiFinder. It was better than I thought it would be at first, and since then it's better than I could have hoped, because people have contributed things that I didn't know that I wanted, and I can talk about a few of those community improvements. I've also gotten an incredible amount of engagement. So I've designed and released other open source projects, but never to the sort of passionate audience that I share the sort of night sky with. So people have provided great suggestions. I've met people at star parties that are like, "Hey, what is this thing?" And it gives me a chance to kind of reach out. I've had sessions like this where I get to talk to amateur astronomy clubs. That's fantastic. People reach out to me, "Hey, I'm building this PiFinder. Can you help me with this?" So I've made friends. I've met wonderful people, and I've really learned more about the hobby by talking to folks. "Hey, what kind of telescope do you use? How do you use it? What's your favorite thing to observe? What catalogs can I add?" So it's been just incredible in that respect, and that was not something that I anticipated when I set upon the task of kind of building this PiFinder. I've also got more observing time, and that means that I've used the observing time I had more productively, I think. But also I've gone out and I've done more outreach, and I've gone to more star parties, and I've just observed more. Because I now have a little bit of a motivation. I could go to the club night and I could observe for myself. Maybe if the weather's kind of iffy, or if it's cold, or if I'm kind of busy, I might skip that dark sky weekend. But now, hey, I have to test some new PiFinder features, or I'm meeting someone there who's interested. So it sometimes gives me that little impetus to get out under circumstances where I wouldn't. I also ended up with a lot of businessy stuff, which I wouldn't necessarily recommend, but I mention it here as a kind of careful when your hobby becomes something more than a hobby. It hasn't detracted enough from the overall enjoyment that I would, trade it or otherwise have a second thought on that. But it's something that I also didn't expect that kind of came along with this. So how much observing have I done with the PiFinder? I don't think this is a current count. I have different development units, but this is one unit that I had that I think I used the most. I've observed over 80 sessions, 369 distinct objects, and 41.2 hours. It's pretty good, I think. And I'm kind of a metrics, nerd. So having this is kind of fun. I like to some degree the stamp collecting aspect of our hobby, where you get to check off lists and say that you've seen certain things. So this kind of floats my boat. I thought I'd include it here because it's interesting, and I feel like that's a higher number than it would have been without the PiFinder. And I've forged a lot of personal connections. So it's been something like 21 months ish. I was looking back, I've had 1.2 thousand email conversations with people, which is crazy to think about. I've been to 5-star parties that I would not have gone to probably otherwise, plus other observing events. I've talked to 350 people that have come to our Discord server and asked questions or made suggestions or just had interesting stuff. That is kind of out of date. I've built now several hundred PiFinders, and I've made a ton of new friends. So, and ultimately, I've sat under the sky with a ton of folks talking about the hobby, and I would not have had those conversations previously. So, I guess I'm grateful, and I include this at the tail end of some of these presentations to show how incredible I think our community is, and how this has helped me engage with it in a way that I did not imagine that I would have previously. So with that, I am happy to answer any questions about essentially anything here or anything else you think I could opine on productively. Happy to take them.
Cool, excellent. Anyone?
Thank you. Thank you.
Anyone in the room have a question for Rickard? I know I do, but before I do that, how about anyone on Zoom?
I've got a question. I've got 2 of your units. And I'm embarrassed to say I really haven't started using them yet, even though I bought them over a year ago. Have you? I had emailed you a long time ago. Have you added the PoE Ethernet support for them yet?
No. And I'm sorry, I might have missed that because that's not even in our feature backlog. So for those that may not be familiar with the term, power over Ethernet is a way to plug in a single cable and both power and provide network connectivity. And I've actually been going the opposite way of probably going away from the physical network port in some of the new designs. You can see that this one doesn't even actually have it exposed, the newer one. So if you would like to add power over Ethernet support, I would be happy to tell you how you can do that. You could take the PiFinders that you have apart. You could add that in. I could show you how that's done. That's a really interesting use case. Yeah, is that for like an observatory?
Yes.
Yeah.
I have a large observatory of my own, and I've just recently completed building an observatory for a college, and I'm going to be building multiple observatories down in New Mexico.
Awesome.
And for me, it's very important to have them networked. It's very important to be able to talk to it from another program because my observatory, I didn't even go out. It's only 60 feet from my house, but I operate it entirely from my basement. I don't even go out there anymore. It's a 15-foot diameter dome that I designed and built myself. 16-inch telescope with a 4-inch, 16-inch Newtonian with a 4-inch and a 3-inch refractor bolted on the sides, all co-aligned. I just want to be able to you've got a web interface that I can talk to.
Yep.
So the Ethernet connection and is very important to me. And Ethernet PoE, the issue really is the box design, and I would have to design a new case. The unit I have is quite old, at least a year old, and I think you've done quite a bit of updates since then. I probably need to just go through and update this whole thing. The other question I have is, I probably can figure a bunch of this out myself. Could you tell me more about the solver that you use? I know your program is written in Python, but is the solver written in Python or in C?
The solver was originally all Python, pure Python implementation. But what actually was taking the longest was the image processing to centroid the stars. And so we replaced that with a Rust image processing system. That was contributed by Steven, a great guy. He runs a Cedar project, which has an implementation of the centroiding, the star detection system, and also he's forked and improved the Python solver, the pattern matcher, the pattern generation and matcher. So the pattern generation and matching is still done in Python, plenty fast, but now we're doing the image detection, the star detection in Rust because it was the slowest part of the process.
I need a plate solver that's I can call from C or C++.
Mm,
Do you have one to suggest?
yeah. The algorithm itself, once you get your head wrapped around it, is actually pretty easy to implement. So I think you could use the Cedar, Tetra 3 algorithm, and I think it would be pretty easy to implement in C if you really wanted something that was like a library that could be called that way.
Yeah, I'm desperately need one.
Yeah. Otherwise, I mean, you could shell out, you could use interprocess communication. So you could, in fact, the Cedar detect system does some amount of GPC calls. So you could use that as a bridge between your C program, the centroid or the camera imager, and then also the solver. Lots of fun stuff. Feel free to reach out. I love nerding out about that stuff. I'm happy to provide any advice I can about the current source code and such.
Yeah, like I said, I emailed you quite a bit over a year ago, I think it was, when I first got these, and then, like I said, I'm embarrassed to say I actually haven't gotten them installed yet and actually used them, but I'm right now working hard at getting things back up and running and work on this new observatory with this college that I'm gonna probably get another one for them.
Okay. Well, I look forward to hearing from you again. And sorry if I let our conversation peter off there.
Any other questions out on the Zoom room? And are there any other questions in the room? I had one. Oh, Bart, did you have one?
Quick one, I think. I think I saw on the site there's like different versions of the PiFinder, and it's now like a PiFinder 3. Can you just give us a very brief what's the latest difference between early and latest one?
Sure. I don't know if I have any. Well, I have some previous photos probably scattered throughout here. So there's really the primary difference was we went from a large lens and camera assembly that was heavy and took up some space to this current camera and lens, which is both smaller, lighter weight, and can take exposures more quickly. So it's better. It's more sensitive. That was kind of the big change between like what we call the version 2 and all the subsequent versions, was this switch of camera. The software is universal. It'll work with either camera. The old camera is still great. It'll give you like 5 or so plate solves per second. The new camera can do the 20 plate solves per second just because of the shorter exposures. With the change in the camera, we did a case redesign to take advantage of the smaller size and the smaller weight of the camera. And the photos that you see here are what we call the version 3. The version 3 is not really designed to be assembled by hand. So this is like the commercial, if you want one assembled, this is the one you get. I went with a kind of manufactured, assembly line version because I just couldn't build them fast enough for folks. So if someone wants one pre-assembled, this is the version pictured here that they get. If you build one of your own, it looks almost like this. I think I have some photos here from previous slides, but let's see. Yes. So this is what the DIY version looks like. And it's just a little bit different. It functions identically. It's just designed to be assembled by hand, so it uses a slightly different set of parts. But really, the only difference is right now is the version 2.5 DIY version looks like this, assembled by hand. The version 3 uses reflow technology, so you can't actually assemble those boards. You could purchase them assembled, and all those files are available online, but that's kind of a bigger commitment in sourcing parts and all that jazz. So if you want to build one yourself, the 2.5 version is the latest kind of build it yourself.
And the new one, do you have a version of the case for the new one that's got the Ethernet port exposed?
No, and that's why I was saying that I've been actually going the other way. This doesn't have the USB ports exposed or anything like that. You can't even, well, you can unscrew it and get to the SD card, but the pre-assembled versions have become more and more like appliance-like and less computery. But the DIY version is what I'd suggest if you want to like plug it into Ethernet or have more expansion capabilities, because that's really what it's designed for. Is just to be sort of a little bit more of a project. You can make it your own, you can customize it, and I think that's one of the coolest things about it. Honestly, I still love the one that I've customized and been observing with for a couple of years now.
I do a lot of CAD design, but and I have my own 3D printers, but I'm cautious of trying to modify the case because I have no idea how you have the files designed, and I probably don't have the same software to be able to modify your case. So if you could come out with a case for the 2.5 version that does have those holes for the Ethernet and the USB, I would greatly appreciate it.
Yeah, sure. If you get in touch with me, I can easily send you a file in STL with a knockout for the Ethernet.
Okay. And
Just
I looked at
oh.
my records. I bought it in January of 24 is when I bought the units from you.
Okay, that'll give me a sense of what it is, but I think that's still the same DIY case.
Yep.
How dark skies do you need for this to work well? Like what Bortle number?
Yeah, it's a pretty common question. So I use this routinely under the skies of downtown Los Angeles. It's got to be Bortle, I don't know, 7, 8, probably. And the reason why it's actually been pretty popular for outreach with our club is that these are skies that you just basically can't star hop under. There are just not enough stars there. But if you get your scope on like an open cluster, or some other objects are still actually showable at a public star party. And so even under what would be considered suburban urban transition, I can see maybe naked eye just like a dozen stars, like you see Orion and maybe part of the Big Dipper, and that's kind of it. It'll plate solve. It'll just take longer exposures. So instead of 20 plate solves a second, you might get 5 because it needs to just kind of have a longer exposure to tease out those low signal stars that are there.
Cool. I've got a quick one. It's I had to leave the room early for a second, so I hope I didn't miss this. But how do you align this with the visual axis of the telescope?
I should have put some slides in there because that's another interesting thing. Originally, we had a sort of 3 thumbscrew mechanical system that had a cell that the camera sat on, so very much like aligning a Telrad with its 3 different thumb screws. But we did away with that pretty early on when we came up with this digital alignment system. So the PiFinder can see 10 degrees of sky. It's about 20 full moons. And unless your bracket on your scope is like visibly, kind of off kilter, there's almost a certainty that 10-degree patch of sky that the PiFinder sees is going to coincide with the half a degree field of your telescope somewhere. And so the trick is, how do you tell the PiFinder where in that 10-degree field to put objects so that they end up where your telescope is pointing? And we've come up with a system where you just point at any star at all, and you then use the arrow keys on the keypad to select that star on a star chart. You don't need to know the name of it. It doesn't need to be a particular star at all, just anyone that you can recognize. And that will then tell the PiFinder exactly where to put objects when you ask it to point to a particular thing. And therefore it will end up, where your scope is looking, and hopefully right in the center of your eyepiece. If you had put the star in the center of your eyepiece.
Cool. Neat.
Yeah.
Any further questions? Kistis, are you with us out at the lake? Let me see. I think he's in our list here. Yep.
Hey, everybody.
There he is.
Yeah, I've been
Turn the
listening
video
in.
on.
Here, I don't know if you'll be able to see much here because it's pretty dark, but let's see.
I'm gonna pin him up. Yeah, it is definitely dark. You got a red
Yeah.
light or something you can put on things?
Let me see.
There
Maybe
we are.
Oh, hey.
Hi there.
blinding myself, but there's my PiFinder. Yeah, pretty dark to be able to show much, but yeah, while you've been talking, I've been observing live with my PiFinder out here at Lake Taconic State Park, and there's actually 4 of us out here. The other guys are doing some astrophotography, but we were a minute ago looking at the Orion Nebula before it sets, and through a big daub. Of course, it's beautiful. But yeah, I got my PiFinder yeah, I think about a year ago, like early last summer, when I got this big daub, and I thought, you know, I got to be able to find these faint fuzzies, and I need something to help me, but I didn't want to do alignment and, you know, all the stuff that you talked about. And so PiFinder's been amazing. I've used it tons and tons. I'm on the Discord, you know, watching for updates and stuff. The latest update, by the way, with the like really small increments for changing the brightness when you get down to dim levels. I just got to try that out, and that's awesome. I was able to finally get it really as dark as as I like it, so that when I'm looking through the eyepiece, I can have it right next to me without blinding me. And so yeah, I don't know how much of like a real demo I can do just because it's so dark, but you know, so I heard somebody was asking about like how dark does it need to be. Here it's dark, of course, but I use it at home in like Bortle 5.5 when I have street lights around and stuff, and I mean it works just as fast as out here, you know, as you move it around, and as soon as you pause for a second, it just instantly updates. And the alignment is so easy now that I don't have to leave it on this scope. I switch the PiFinder between this and my refractor and another reflector or two, so I can easily just swap it over to the finder shoe, do a quick alignment, and you know, I'm ready to go and can find whatever I need. But yeah, so I don't know. Yeah, I don't know if you want me to try to show you anything, because it's I realize it's pretty dark. My camera's not able to really show you, but yeah, I just wanted to chime in that you know, I was gonna watch this from the comfort of my house, but then you know, we've been missing some good weather, and tonight's like super clear. Actually, it's amazing, not a cloud at all. So we're having a good time out here.
I'm curious to know if you switch to the other camera on your phone, if it would be a bit more sensitive than the normal front-facing camera that you use.
Well, I'm actually, now. Yeah, I'm actually not using my phone. I have my my laptop.
Oh, never mind then.
Yeah, it's easier to set it down. So unfortunately, the laptop only has the one camera. But let's see. I'm trying to see how much I can show you without blinding myself too much here. But
yeah,
I think the further I get,
it's great that it just goes to show how dim the PiFinder can get, because it looks like it's off essentially right now with that level of exposure.
Screen. Yeah, that's right. Well, see, I can get really close, and I mean, yeah, I don't think you can.
Oh, there you go. You can see a little bit, maybe.
Yeah, I can maybe see some numbers, but yeah, it gets very dim. And I mean, you can see I've got it like, here's my eyepiece right here, PiFinder's up here, and I really like the placement that way. But it was always, you know, a little bit bright, and sometimes I'd like have to block it with my hand or something. So now it's now it's fabulous.
That's an example of, you know, we get feedback from folks, and we, you know, have software contributions from myself, and there's a lot of other people that contribute now to the code base. So we're able to, you know, help out. And if anyone has Python experience, they can, you know, make that change themselves, make it better. So that's great.
Quick question in the room is, how is it powered?
So yeah, there's an internal battery that's good for between 4 and 5 hours of observing, and it's chargeable via USB-C, or you can plug in an external USB-C source. My scope has power on board for Dew and other things, so I just plug it into my scope power. But that makes it a little less kind of self-contained. The nice thing about the battery is, as Chris was saying, you can move it from one scope to the next, and, you know, all night just be flopping it between different scopes without too much of a hassle. So.
Yeah, and yeah, you're asking about mine. I think you can plug it into a battery. Also, I have the internal battery, And I've never had it die on me before I fell asleep. So I've I've used it from like I think 9 p.m. to 2 a.m. or something. I think is the longest I've gone, and it still worked. I'm guessing, and you probably know better. I'm guessing if I moved it around a lot, I was doing like a Messier marathon or something, then maybe it would die a bit sooner. You know, if I'm just kind of sitting looking at objects for a while, then it seems like it can really go longer than I can, and then I just plug it in when I get home, and it's good to go.
Yeah, that's absolutely right. If as soon as you stop the scope and you haven't shaken it or pressed a button, it will go into a sort of low power mode, which is nice because it dims the screen even further. So if you're up close to the eyepiece, but it also does save battery. And then as soon as you move the scope again, it'll wake up, or you press a button and it'll wake up. So depending on your observing style, you may get 4 hours if you're really active going from object to object, or you could get considerably longer if you take your time and kind of really savor each and every one.
That's very cool. Anything else? More questions? Kirsten, thank you very much for that little live display at the park. That's very, very cool.
Yeah, this is awesome. It's the first time this has happened, and it's just amazing.
There you go.
All
First
right.
time for everything.
Yeah.
All right. Thank you so much. It's been a pleasure. All right. With that, we'll call this to a close. Those of us who would like to join us at Pasquale's. Oh, I do want to point out one thing before I go. You notice he's on Discord. Sorry, Discord. Hint. Discord. Yeah, Discord's on Discord. Got a little talk about that. I'm trying to get him to move to that regard. So.
Great.
All right.
I'll join up. But thank you, everyone. Thank you again, Bart and Jack, for helping to facilitate, and I'll send through information. But it's been a pleasure. Thank you.
Thank you very much. Have a good evening.